Okay, well, let's get started. Week 13, right before fall break. I'm going to continue with and hopefully finish everything I want to cover with live coding today. So last week we talked about NodeProxy. We also introduced the alternative syntax styles with Tdef and proxy space. We talked about play and stop, send, release, the idea of a source, fade time, and all that sort of stuff. So just getting the basics of being able to generate and manipulate real-time modules that can be arbitrarily filled with sounds. So today I would like to talk about how we route and patch and interconnect node proxies. This is something that we have done, outside of the NodeProxy context, with in and out and order of execution and groups and things like that and buses. So it's considerably more straightforward when you're dealing with NodeProxy objects. I also want to talk about clocks and quantization, because if you're doing a live coding thing and you want it to be rhythmic, you need to basically pick a tempo and set a quantization value, and NodeProxies will lock to those parameters. There's another proxy object called Tdef, which is, I guess, a subclass of task proxy. It's basically like the live coding version of routine, which lets us specify a sequence of arbitrary code, and we can lock that to a clock and a quantization and things like that, but we can dynamically redefine it. There's also a method called Reshaping, which determines how a node proxy reacts if you fill it with a source that has a different number of channels, like sort of two-channel, like stereo, like an array of two things, and suddenly it's four things. You can control how it reacts to that. And the last thing is that we've pretty much been using UGen functions as node proxy sources, but you can also use a Pbind as a source, which is really cool. It's very convenient. So I have some code here. I'm going to work, I think, today just entirely inside of a proxy space, so we're not going to do any Tdef stuff, but most of the stuff I show will translate pretty easily to other styles. And you will hopefully remember from last week that with proxy space, we can kind of do a lot of things in just one chunk of code. So we create a proxy space stored in the interpreter variable P. Its server is the usual localhost server S, which we boot in the process of naming that server. Proxy space also can have a clock attached to it. And so I'm just creating a tempo clock stored in T. We probably don't even need to give it a name here because we can access it through the proxy space. But I give it a tempo, 90 beats per minute. It's permanent. And then we close the proxy space and push it so that it is the topmost environment. So we will do that. A bunch of stuff happens. And we can check a couple of things. P.clock gives us this tempo clock, whose tempo is 90 over 60. One thing that's nice about being inside of a proxy space is that any node proxy objects created when a proxy space is the topmost environment will adopt characteristics of the proxy space, such as its clock, its quantization. You can set a global fade time. For example, p.fade_time is nothing, but we can set this to 4. And now we can say p.fade_time and just check that value. It is in fact 4. And so if we just say, a.play, and we say a.fade_time, it just automatically pulls that fade time from the proxy space. Similarly, if we say, let's see if there's a default quant value, which is 1, which means anytime a node proxy is playing and you set its source to be some new thing or some other thing, that change will begin on the next beat multiple, multiple of 1, basically. And we can set this to be every 4 beats. You can see we still have this proxy that we created, and we can say, we'll put it down here, I guess, a.quant, and sure enough, it's 4. Right? So this is a nice. You can do this with Tdef. I mean, basically, behind the scenes, there is an instance of proxy space created for you when you start using Tdefs. But it's very much the same thing. It's just here we explicitly create it. We can set its fade time, give it a clock, give it a quant, and all proxies adopt that. If you want to override one of these values, you can. You can say, I don't want A to have a quant of 4. Let's say, we'll say B.play. Well, let's make a new one, right? B.quant, set that to 1, and that's totally fine. So B.quant is 1, but A.quant is still 4. So you can override these if you want. Let's get rid of these. Okay. And just checking here. Right, we're still in our proxy space. It is our current environment. I have some other stuff here. I'm using the interpreter variable B. We don't really need buffer.freeAll there to make an empty event. And I'm storing in that event at the key glitch a bunch of sound files in this glitch folder that I have, and I'm just reading each one of them in as a one-channel file. So I'll do this, and do this separately. We don't need to do these separately, but we're going to. So there we go. All those files are loaded, and they're just little crunchy things that I've created at some point. Just little fun percussive things. So now we can say b.glitch 0.play, just to make sure it's working. So all good. And I made 2 synth-defs for myself, because if we are going to be using Pbind as a NodeProxy source, we do need a synth-def, right? Because the first thing when we want to have a Pbind and play it so that it makes sound, it needs to know which synth-def it's using. So we do a little prep, I guess. I mean, this is how I approach it in SuperCollider. And I just have 2 instruments. A is a low-pass filtered sawtooth wave, which is panned and which has a percussive envelope. And B is a play buff, so it's just going to be the thing we use to read those files. So okay, we got our sawtooth, and we can say cutoff frequency 300, 3000. Yeah, so that's all. Just normal stuff. Synth B, buff B.glitch 0. Right. And I think the release is maybe a little short, so we can hear the whole thing. Okay, so that's just all we're going to have to sort of get started here. So let's get back into our live coding sandbox stuff down here. So let's make, I was sort of messing around earlier today, kind of just trying to do live coding performance sessions, and it went pretty well, just kind of tinkering around. It's very messy, right? Where, you ever seen that show about hoarders with Marie Kondo, and she says, "I love mess." That is the mentality we're going to get. We're just going to allow the code to just be what it's going to be. We're not going to worry too much about it. We're just hoarding code here. Okay, let's play this. So it's got a 0.02. That's, I thought it had, what is the proxy's fade time? 4. That's, okay, so if we, maybe that's because we cleared it. I wonder if that's what happened. Because if we clear it, I actually need it. Let me just see this real quick. So if we say c.play, c.fade time, 4, c.clear, play. Yeah, that does reset the fade time. Interesting. I wasn't expecting that. That's okay. ABCs are just little test cases. So let's make let's just get a sort of ambient pad thing going here. So I'm gonna say pad.play, and we're gonna say I'll just give this sure, why not? Okay, nice little mellow tone here. So let's talk about routing and patching. First, we're going to go upstream, and let's say we want to actually modulate this tone with something. Now, of course, we can just, let's see, what do we want to modulate? We could do amplitude. I guess we could do like a filter thing. Let's just do amplitude for simplicity. So we can obviously do stuff like this. So we have a 4-second fade time. Right. Make this a little bit louder. Scale this up. Okay, so we can just plug a modulator into the function here, but if we want to do something, if we want to use this modulator elsewhere, so that it actually affects multiple node proxies, then what we can do is we'll just get rid of this for a second, go back to our original version. And we're going to make another node proxy. We'll call it pad mod. And we're not going to play this one. We don't want to actually play the modulator. That would actually route it to speakers, and we'd be hearing this well, we wouldn't hear anything if it's a low frequency sine wave, but just, it's important to not instinctively play every node proxy you create, because not all of them are meant to be heard. Some of them are just meant to influence other signals. So I'm going to paste this in here and just say this pad mod is going to be this low frequency sine wave, and we just create it, right? It's created. We run the code, and now we can go back up here. I'm gonna copy and paste it just for teaching purposes. Normally I wouldn't be, duplicating all this code, but then we can say sig equals sig times pad mod, and there's only a couple of things you really need to do. I think the best practice here is to specify rate and number of channels. Okay. And now we can go and mess with this one, make it not, change the range so it doesn't get completely silent. We can make this fade a little bit faster so that when we change it, let's change the frequency. And also it's quantized, don't forget. Right, it's got 4, yeah, and another thing that I'm maybe could be doing a little bit differently, just kind of bring this back so I can sort of talk over it more easily, is that the fade time is 4, which I'm actually not 100% sure whether that is in the context of the clock or a hard 4 seconds. Not really sure, but. And we could figure that out, I suppose, by making clinical sounds and testing it out. But if you want to set the fade time, the global fade time, to be relative to the clock, instead of this, like if assuming this is a hard 4, but we're at 90 beats per minute, right? And let's say we want to do 4 beats of a fade time, we can say p.fade_time is going to be p.clock.beatdur times 4. So p.clock, or we could also do t, because we named it t. Either way is fine. We access the clock, and the beatdur method tells us exactly how long one beat is. Yeah, and then we say, I want the fade time to be 4 beats by just multiplying that value by 4. So that's something we can do. And then let's just see. Yeah, it looks like they all adopted it. Every proxy we've created has just, as soon as you set the fade time of the proxy space, all proxies are informed of that change and adopt that fade time. So probably something you'll do at the beginning, instead of in the middle, but it doesn't really matter. All right, so we've routed this in here, and so then we could.
If we change the fade time right off the bat, does it also do does it ramp between the 2 quantization times maybe?
Oh, okay. So.
On our fade time?
All right, so if we have, if we've set our fade time to be 4 beats and our quantization to be, let's say, every 4th beat, then when we make a change, it will activate the change on the next whatever the next 4th beat is, and that's when the fade begins. So it will actually, it'll wait for the next beat multiple 4, start the change, and then over the next 4 beats, it'll crossfade with the previous source. Does that answer your question?
If I'm changing the quantization time on the fly.
If you're changing the quantization, the quantization, when you change the quantization parameter of a node proxy or of the proxy space, that's an instantaneous change, but it only takes effect when you actually play or change the source of something. So I think if I were to change this here, right now, let's just see what the quant is. It's 4. So if I were to make this, you know, instantaneous or something. So if I start this and then change that, it's too late, right? It's already used the previous quant time to initiate that change, and it's so you never really dynamically change the quant time. You can change it, but it
So it won't influence what it's sounding right now. It will influence the next trigger that you will.
yeah, right. So let's
What I understand.
right. So now this should be fast. Yeah, because it just waits for the next fourth beat, and then no, sorry, I'm messing this up here. I wanted to keep this the same, and then make this fast. Sorry, that's pad mod. See, we love mess. We're just going for it here. So for this sound source here, this audio rate sound source here, the fade time is very quick, but the quant is 4. So just next, whatever, it's waiting for the next beat multiple of 4, and when that beat arrives, it initiates the change with this fade time. So if we set this to nil and make this like 4, now we have no quantization, so changes take effect immediately, but they're going to start immediately, but it'll still take 4 seconds to fade in. Yeah.
Oh, pretty cool.
Yeah, so it's, I think of quant and fade time as being pretty much independent. You know, they don't really influence each other. Right. All right, so we'll go back there. You know, and again, maybe this should be, I'm not really sure exactly what the right value is, but so we've created a modulator upstream, and so now we could do something like this. Add another, let's make this, sure, pad 2, dot play. Yeah, so we got this other NodeProxy happening here, and it's got the same modulator. A little, yeah, doing some harmonic series stuff. Okay. Yeah. Yeah, because the fade time is short there. Yeah. Yeah. Okay, so that's sort of that's routing in a nutshell, at least from upstream. Let's change this to sawtooth wave, and we're gonna do something like this. Okay, so we swapped it out for a different modulator. Let's do this. Okay, and I'm gonna, so this, what I've done is I've taken the sawtooth wave, the negative frequency makes it be a downward ramp instead of an upward ramp. I then make the range so it's kind of curved, so it's got more of a sort of exponential percussive shape, and I want to curve it even more. So we're using Lin curve to exaggerate the exponential nature, I think. So just imagine that exponential curve getting sort of gravitated down towards 0, because we're going to put some reverb on this. Right? So let's go, instead of upstream for routing with other node proxies, we're going to go downstream. So we'll make this reverb effect. And we're going to say, pad, let's see, what are we going to do here? Well, first of all, the input to gverb, I think, is supposed to be a 1-channel input. Yeah, mono input for gverb. Right? So these are both stereo, right? Because they got two channel frequencies. So for the input, I'm going to say pad.ar 2.sum. So this tells us this is the input source, right? It's going to be this pad, and we're going to mix the two channels together into a one-channel signal. And we're going to add that with the other source. So we're taking both of these sound sources, using them as the input to gverb, and then gverb needs a room size and a reverb time. We're going to be very generous with those. And I like to follow this up with a somewhat aggressive low-pass filter, so it's not so sizzly. And we'll do this. And we might not hear it. I'm trying to be subtle with it at the beginning, just scaling it down. Yeah. And I think I'm going to do, I don't want any quantization on the reverb. I just want it to happen immediately, but I do want there to be a fade time, so that's fine. Right? Got some lovely reverb on that. Why don't we add a delay as well? And this is going to be independent. We're sort of taking the sources from upstream and we're catching those in a reverb, but also catching them in a delay. And so two separate effects in parallel. Yeah. All right, I'm just going to copy this stuff. And we don't need to sum to mono here. We're just going to just sum the two sources, pass them both in here. Yeah, so we're going to use a comb filter. We put the input first, the maximum delay time, and then the actual delay time. We'll say a quarter of a second. And the decay time, how long it takes to decay by 60 decibels, we'll say 8 seconds. And then this parameter here is the amplitude. So we'll start it kind of quiet. And working? Let's see, I might have messed something up here. I did play it, right? Oh, maybe it's just really quiet. Yeah. Okay, so we can go upstream, downstream. The whole idea is that when we start interconnecting, I'm not actually sure that it rearranges things. It's just the whole system is kind of designed so that you don't have to worry about order of execution, and that when something is a source for something else, the back end just kind of figures it out, moves things around for you. Right, so, okay, let's see if I can undo some of this. And go back a few steps. And this. Okay, now we'll keep doing some routing stuff, but I want to talk about reshaping a little bit here. So let's forget about this one, and we'll just focus our attention on this one here. All right, and I'm going to say freak.kr. And I'm not going to specify the number of channels. And this doesn't have a value yet, so, but it should be fine. It should just go silent, I think. And it knows that it's nil, so we're taking a little break here. And let's say freak. We're not going to play this. This is just going to represent the actual frequencies we want to pass into the function here. So if we say 100, let's see if this works. Ooh, it fades in, right? Because that is what fading in means. It's got some initial value which is nil, which I guess is interpreted as 0. So we can. I just want these to have. I don't want to wait 4 beats every time we make a change. I need a little more juice from that modulator. That. Okay, now if we want to pass 2 frequencies, like something like this. So this is, it says kept first 1 channels from 2 channel input. So the default behavior of a NodeProxy when you change the size of its source, and when I say size, I mean number of channels or size of the array. This is determined by an attribute called reshaping. And nil means it will not change its size. I think it will basically either drop channels or wrap them. It's just it won't change its size. But we can set this to be elastic. All right, and so now let's see what happens here. There's a little hiccup here, and I have not figured out why that happens. I think when the size changes, there must be something going on under the hood which, causes it to do that. So we'll add another one. I mean, I wonder what happens if we change the fade time, something like this. Yeah, I think basically what it has to do, here's my guess. I know it's kind of a fun effect, right? It's like, I'll take it, I don't mind. If the number of channels is different, then it has to basically create a new source and fade one out, fade the other in. So I think the first one is faded out, and that's what causes the frequencies to fade to 0, basically. And the next one comes in and fades from 0. But if the channel size doesn't change, then this happens. It knows that they're the same size, and it doesn't have to fade one out. It just actually fades the individual channels. Yeah. So then you can do like, yeah. And so here's another trick I like to use. Let's say I want to do a chorus effect, right? So I could, basically what I want to do is I want to turn each of these numbers into a pair of numbers that are slightly different. So have 72.1, right? So a tenth of a. But I have a mini tutorial on YouTube called Adverbs for Binary Operators. Let me, just gonna allow myself to think here for a second. So normally if we do something like this, this kind of multiplication here, the default behavior of mathematics, of doing mathematical operations with arrays, is it goes sort of 1 to 1, so it's going to take 2 times 10, 3 times 20. It runs out here, so it starts back at 2 and multiplies that by 30. So this is what we get. And what I want to do is have this array, and I want to basically multiply every number, or I guess we want to add here, maybe not multiply, add something like this to every number. And so this will detune half of the notes. This doesn't give us a chorus effect. It just detunes a couple of the voices. So what you can do to these operators when you are working with arrays is you can modify their behavior by attaching what is essentially like a method for the operator. So this .x is like, .quant, .fadeTime or something like that, but it modifies the behavior of the plus. And the x, I think, is some sort of cross product. But basically what it will do is it multiplies each item here by every item over here. And so we actually get 8 values. This is, very fancy. .t is like table multiplication, so it actually doesn't, it gives you a multi-dimensional array, and x will just flatten the whole thing, which is what we want here, right? So if we were to take this, check out the mini tutorial, Adverbs for Binary Operators, if you want to see more of that. So let's bring this amplitude back up again, just something a little more healthy. And we're gonna plug this in here. And we do need to parenthesize this, because if we don't parenthesize, remember methods happen first, so it's going to MIDI CPS these here and then do the multiplication or addition. That's not what we want. So we want to do this first. Ah, yes, very nice. Can make it more detuned. That modulator. I should really just bring this down here so I'm not scrolling up all the time. Yeah, we love mess. We don't care. What else can we do? Divide by 2. Okay. Okay, so that's reshaping. It can be convenient if you want to just suddenly add more voices or something like that. And so basically Freak, see it's basically just been modifying its channel size in order to accommodate our requests here. Okay, let's talk about Tdef now. So Tdef, as I said, is basically the live coding version of routine. So let's say I wanted to multiply, like I'm doing some like melodic stuff here. So we'll say 0.MIDI ratio, and then go down by 5. I want a little faster fade time. And let's say I'm imagining some sequence, and I don't want to have to sit here and constantly babysit this NodeProxy and be like, all right, now change. It's like when it's like sitting there for too long, I want it to change. Tdef is really nice to be able to automate this process. So what we're going to do is we'll just copy this, and we're going to make Tdef. And this is a lot like MIDI-def, synth-def. We give it a symbol, and then we give it some content. It is going to be, we'll call this, we'll give it the same name. Who cares? I think that's fine. And we're going to say loop the following thing. And we're going to say 0, -5, -7, -12.do, pass that number in. In fact, we're going to play this Tdef right away. Just going to get it going. Play it on the clock. So it's playing. It has no definition yet, but it's playing. It's running. So as soon as we run this, and we got to put a wait time in here, right? Do not let me forget to put a wait time in here. We'll say t dot. This is playing on the clock, so we just want to say like, let's do 8 beats or something, 8.wait. And here we want to say i.MIDI ratio. And that should be good. So let's just see, we got a loop, and we're going to iterate over the following 4 numbers and modify the Freak NodeProxy so that it transposes by that amount, and then wait for 8 beats. Let's do 4 beats, just so we can actually hear it. Right? I think it was already at 0, maybe? Let's see. I wonder if I missed something important here. Maybe it needed to be played again, but it's doing it now, so. So then we can just kind of let it live, and just now we don't have to sit here and be constantly changing it. But we can always come back here and do something like this. Actually, maybe this is what's messing it. No, it's still going. Okay. It's gonna go back to the beginning. Yeah, it's quantized too. I think this is. That's interesting. But it's adopted the new stuff here, so we can. following along so far? You getting the gist of what we're doing here? Yeah, let's add a little rhythmic texture with those glitch samples here. So if you want to do something kind of like, you know, rhythmically nuanced, using a NodeProxy with a source that's a UGen function is only going to take you so far. You have to do some awkward thing with re-triggering a play buff and constantly switching out the samples. Pbind is a much better option for, you know, complex synthesis stuff. So let's make a pattern, and actually, let's see if I can do this correctly. There we go. Okay, good. That's fine. All right, so we want instrument B. I think that was the name of the synth def, right? B is what I called it. Very meaningful name. We'll just start it off at just one synth per beat. And the buffers, we'll just say, pick a, well, let's just start with like, I don't know, index 20, amp. Let's use decibels, I'm feeling decibels today. And release, we'll keep that short. And let's see what happens. It's in there, it's in the background. So I'm just giving it the whole collection. Let's give it a smaller collection. I think we can do something like this. Ooh, let's do this and this. It's awfully quiet. So basically, I'm saying sequence through samples with indices 1 through 4, right? Because this is just the array 1, 2, 3, 4. So we can offset this by any amount we want. Let's make it. I want it to be just instantaneous, or very close to instantaneous. And I still want that. Okay. Do yeah, the release is too inconsistent, I think. I just want to trying to find a nice sample zone. Ooh, that's good. Little like kind of 808 woodblock thing going on here. So and then you can do you know, polyrhythmic stuff. Like just add a 5th sample, and it's going to be on a 5 sample cycle. Yeah. And let's go here and parenthesize this and just take it down an octave. And what can we do here? T.tempo, I think is, because tempo is beats per second, and this is an oscillator, so it thinks in cycles per second. So, you know, you can just plug this in here and say like times 4, and then it should kind of follow the clock in terms of pulses. So it should lock up with the pattern. Ooh, yeah, that's nice. Okay. Yeah. I want my reverb back now, so we still have that. And now we gotta plug some other stuff in here. So we'll say patch.ar. And again, it works just fine if it's a pattern, because the output is, you know, we're able to talk to it like a NodeProxy. And what else do we have? Just pad, I think, right? Yeah. I want this sawtooth back again. Go. Oh, yeah, not tempo. Wait, yes, tempo. Yes, thank you. And, I think I set the phase, because the sawtooth wave starts in the middle. So with a phase of 1, this makes it start at the top. Yeah, now it's locked in, yeah. Let's do that. That might be a little cartoonish, but we're gonna go for it. And now I lost my train of thought. I was gonna, oh yeah, do some more delay stuff. But let's first do that. Give us some new samples to work with. Yes, right. You have to adjust your timing expectations with live coding. It's very slow moving, at least when I do it, anyway. And then, oh yeah, I want to get some fun delay polyrhythms going. So we'll go back to our delay. Are you playing? Good, good. And I always kind of forget the math here, but let's just say t.beatdur. Okay. I can't remember if it's 4 over 3 or 3 over 4. Let's see. I'm gonna sequence through everything because I feel like it. Just go through the whole, it's like 70 samples in there or something. Yeah, but we can hear the delay now, right? That's definitely working. Okay, now I'm gonna try to get out of this somehow. I'm gonna wrap up here, so I'll figure it out. I mean, well, you know, I'm just trying to keep this video a suitable length here, but anyway, this is what I do when I try to live code in SuperCollider. It usually turns into this kind of thing. We have a rhythmic thing, we have a chord thing. If I were going to do this for another hour, I'd probably like try to add some bass, get a bass pattern going. You know, maybe some more samples. Who knows, right? Just kind of figure this out. All right, so I'm going to try to unwind here. And what we'll do first is take this and cut the frequency in half of the modulator. Make the curlies. Okay, so I'm just kind of sparsify the rhythm here. Where's my delay? Just gonna fade this out, a little gradual. And maybe I'll stop this Tdef once it gets to a chord that I'm happy with. Sure, why not? So now this will stop cycling through pitches, and I'm gonna just get rid of this. I think we're gonna just detach the modulator from that pad. Oh, this thing has been yeah, wrapping to 2 channels the whole time, I think. So because this one is not elastic. So we're feeding it this big array, and it's just those 8 voices. It's going, you know, left, right, left, right, left, right, left, right. It's just kind of fitting that into the 2-channel thing here. Let's do. Oh wait, I'm going the wrong way here. I meant to make it, I'm reducing the duration, right? But actually what I want to be doing is just, yeah. There are no mistakes, only opportunities. It's, and there we go. Ta-da! Okay.
Woo. Thank you so much for showing us. It's very helpful.
It was very inspiring.
You are welcome. I'm glad it was helpful and inspiring. Yeah. What I should have been doing is using the history class to record all of that, but I always forget to do that. So it's lost to the ether.
It's in the YouTube video.
Yeah, it's in the YouTube video. Right. Okay. Good. Okay. I hope this lecture might serve as a reference down the road if you want to sort of get back into it and remember some things. What I plan to do for our last class after fall break is we'll step away from the live coding tools, and I'll try to go through a very basic structural approach for creating like an electroacoustic piece in SuperCollider with live processing effects. So not live coding, but but something dynamic, or this is this is your question basically, which is like, yeah, how do you actually approach a live processing electronic music piece in SuperCollider? So like tracking the amplitude and using that to just dynamic effects based on stuff like that. So I don't have much of a plan right now, but I'll figure it out. And if you have any specific suggestions on problems you're encountering or things you'd like to see, just let me know, and I'll try to work it in. So that's it for today. I hope you all have a great break, and we'll reconnect afterwards.